Hello, everyone. Thank you for joining today, this installment of Boyce Thompson Institute's Breaking Ground discussion series. My name is AJ Bushy, and I'm in the communications department here at BTI. And for this month's Breaking Ground, we welcome Dr. Sarah Evanega, a plant scientist and science communicator here at BTI, whose main research focuses on science disinformation and misinformation. And today we'll be talking about Sarah's research into the public perceptions about biotechnology and GMOs. Hi, Sarah.
Hi, AJ. So great to be here today. Thanks for the invitation.
Thank you for joining us. And before we get started, a few housekeeping announcements. During this session, which will be about a half an hour, all participants will be muted. That's the discussion part of the session. And then we'll have about a half hour Q&A with everyone out there in Zoom land. And you can ask questions right in the little chat box. I'm sure everybody's familiar with that at this point. And I've also enabled a live transcript button, so you should be seeing closed captions at the bottom of your screen. And if you want to turn that off, you can do it. There's a little live transcript button, a little CC down there. You should be able to use that, adjust your settings down there. And thanks again to everyone for joining us today. Let's get right into it. So Sarah, could we start off? Could you just tell us a little bit about yourself and how you ended up at BTI and doing the research that you do?
Yeah, absolutely. So my name is Sarah. It's so nice to be here. I'm a plant scientist by training, a science communicator today, and a mom of 3 kids. I grew up in a tiny little town in Northwest Illinois called Rock City. It was not a city, it was a village, and there were no rocks, so a bit of a misnomer. But it was a place where, I didn't grow up on a farm, but we were surrounded by farms and people leading lives in agriculture. And so perhaps a little bit of that was in the water, if you will. I found my way to Reed College in Portland, Oregon, where I did my undergraduate degree and studied biology. And it was really there that I discovered the amazing world of plant science. And I had a fantastic professor there, David Dalton, who was a plant biochemist. And it was just so exciting to me to see the reactions I was learning about in organic chemistry happening in the pathways we were learning about in plant physiology. And so I pursued study in his lab. I worked on nitrogen fixation, biological nitrogen fixation, and spent the summer after taking that class isolating leg hemoglobin from soybean, from a recombinant system. But so that's the red kind of hemoglobin-like substance in soybean root nodules that makes the Impossible Burger bleed. So when Impossible came on the market, I was like, oh, I know this like hemoglobin. I've spent many nights isolating that stuff. But that was really what then led me to Cornell to pursue a PhD in plant science and plant biology. And many people may not know that my first sort of time at Cornell in plant science was spent right here at the Boyce Thompson Institute, where I did my first rotation. And at some point during my PhD, I felt like, wow, I have all this great knowledge of plant science. How can I bring it out to people? How can I work more at the interface between science and society? And that's when I really took the plunge into science communication and science advocacy, and wrote a fairly non-standard dissertation on the controversy around genetically engineered crops in developing countries, and focused a lot on the case of the virus-resistant papaya that really saved growers in Hawaii in the 1990s. But I came to plant science in the mid to late 1990s, and that was the same time when the first genetically engineered crops were coming on the market. Yep. And it was such an exciting time to be in plant science. And today to see so many more genetically modified crops reaching the hands of farmers, it's a great time.
So in a way, you've come back home to BTI. It's great to have you.
That's right. It all comes full circle.
Yeah, it's interesting. You mentioned, the late 90s when a lot of this stuff was kind of first taken off. And I started my first job out of college at Nature Biotechnology around the same time, 99, 2000. And there was a lot of, frankenfood, and there's a lot of people, really against GMOs at the time. And so I'm curious, the title of your talk is The GMO Debate is Over, but is it really? Or the GMO debate is over. And I guess my question is it really? Seems like GMOs are still a very contentious issue. and I see non-GMO labels in grocery stores. So I'm curious why you say the debate is over.
Yeah, so I'm really keen to jump in on this topic today. You know, we still do hear some people groaning about GMOs, but I think that's a really loud and vocal minority of people. Most people just aren't concerned about GMOs. They've got other issues on their mind. So I'm going to go ahead and share my screen and share some slides here today.
Okay, great.
Patient with me here. Okay, is that coming up okay?
Yep.
Great. Okay, so I've told you about me. So I think, you know, AJ, you know, at the Alliance for Science, we love a good story, but we also like good data. And so I want to start today by sharing with you some of the data that suggests to me that this debate is over, and then we'll end with some stories, because we always like a good story. Okay, so I want to start by sharing some data from an organization that I really appreciate, the International Service for the Acquisition of Agrobiotech Applications, or ISA. And this is an organization that has for many years now been tracking the growth of biotech crops around the world. And so, you know, the latest data that I have from ISA is from 2019, and essentially what we can glean from their latest brief is that 29 countries around the world are growing GM crops, okay? And 43 countries are importing biotech crops. So they're all around us. And that's being grown on 190.4 million hectares, okay? So that's a lot of area out there where biotech crops are planted. And I want to point out that this is not just something that happens in developed countries. Developing countries actually grow more of the biotech crop area than in industrialized countries. So this is scale neutral technology. It's great for large farmers. It's great for smallholder farmers, totally scale neutral. And if we look at the great data that ISA has curated for us across the decades from 1996 to 2019, we see that biotech crop production has increased 112-fold over those years. So this is a very rapidly adopted technology by growers. I think we have a hard time getting growers to adopt some technologies, not biotechnology, because the technology speaks for itself when it's out there in the field. And if you look at some of the countries that are producing the most biotech crops, like the US, Brazil, Argentina, Canada, and India, those are the top 5. You see that among the major biotech crops that are being grown, so this is corn and soy and canola and cotton, for example, the adoption rates of those crops in these countries are almost at saturation. So almost all of our corn and soy, for example, when averaged out in the US is biotech. So they're all around us, okay? We're eating it, we're enjoying a plentiful food and a very affordable food supply here in the US and many other countries around the world. We also know that, you know, GMOs are safe, okay? This is like tried and true technology. There's been well over 3,000 scientific studies that have assessed the safety of these crops, both in terms of the safety for human consumption, as well as the safety for the environment, which of course is important to all of us. And almost every scientific institution out there has recognized the safety of GM crops, including, you know, the American Medical Association, the World Health Organization, the American Association for the Advancement of Science, the European Commission, the Royal Society of Medicine, the World Academy of Sciences, all kinds of scientific societies from all around the world, from all continents, recognize that GM crops are safe for human health and they're safe for the environment. So that should give us a little bit of confidence. But if we just drill down on the US, for example, there was another great, robust study conducted and published in 2016 by the National Academy of Sciences here in the US. And they brought in experts from all kinds of different fields, from economics, from social sciences, from the life sciences, to look at the data over the last decades. And once again, they came to the same conclusion that there is no evidence of a difference in risks to human health between currently commercially available genetically engineered crops and conventionally bred crops. And
so if I can
find any conclusive cause and effect evidence of environmental problems associated with genetically engineered crops. So again, this kind of robust, thorough study gives us further evidence that there's really no reason to be concerned about this technology. And I'm sorry, AJ, I cut you off.
That's okay. So I kind of think of GMOs as, the technology is neither good nor bad. It's how you use it, right? And it's all about the end product that could be beneficial, has different risk-benefit profiles. So these studies, they're looking at them all across the board. Are they looking at each product individually? How exactly are they?
I think both. I mean, you have to look at each, you have to look at these on a case-by-case basis. And I always encourage everyone to look at every application of genetic engineering on a case-by-case basis when you're thinking about how you feel about this technology. And you can love one GMO and not, be in love with another GMO. That's okay. So a lot of people who, for example, are really keen to see pesticide use reduced in agriculture might, be really excited about, crops like the BT eggplant that I'll talk about in a few minutes that has significantly reduced insecticide use in agriculture systems in places where it's grown. So, I mean, it's important to look at them all on a case-by-case basis. That said, in this study, they not only looked on a case-by-case basis, but they looked at broader impacts as well, societal impacts, who benefits, who loses, and so I think both looking at the sort of micro level on a case-by-case basis, but then also like panning out and looking at the big picture, all led to this very robust conclusion.
I think that's very important. I know we'll talk a little bit later about who benefits.
Yeah. I mean, so this is an example of the US and a study that was done in the US in coordination with scientists from around the world. Europe often gets a bad rap when we talk about GMOs, but there was a new Eurobarometer study that came out from EFSA, the European Food Safety Association, in 2019. And an interesting observation in this study, which covered a lot of different issues around food safety, not just GMOs, but they did note that concern about GMOs had more than halved in the 9 years since their last study. So Europeans just aren't that concerned about GMOs anymore. That's good news. There's plenty of other things in the world to be concerned about. And so I think, this is good news too for our friends in countries where a lot of opinions from Europe actually impede policymaking and impact in other countries. So for example, I have a lot of friends on the African continent who are quite frustrated when NGOs and other groups that oppose biotechnology, come from the US or come from Europe and sort of stand in the way of the impact that these crops could have for producers in Africa and elsewhere. So Europeans, they're not even concerned so much about GMOs anymore. And at the Alliance for Science, we do a lot of tracking of this issue when we look at the conversation around GMOs on social media and in traditional media. And so I want to share some of the insights that we've observed in tracking those data over the last couple of years. And 2020 was a really interesting year for many reasons. But when we compare 2020 to 2019, we see that the visibility of the GM issue decreased by 26%, and the sort of relevant social posts decreased by 39%. So people really just weren't talking about GMOs in 2020 as much as they were in 2019. Obviously, that's not all that surprising considering the pandemic that we've been through, but there's some other interesting insights related to that. So I'm going to show you this kind of big slide. It's got a lot going on in it, so we'll take a minute to take it all in. So this is our sort of tracking of the conversation around GMOs across all media on that top line in traditional media, and this is English language media, top tier media set, and then social media in that third line. And then in the last bar graph there, you can see sentiment across this timeline. So this is 2018, 2019, and 2020. And what we see is that across all media, the conversation is more favorable. Okay, so we go from 73% favorability to 78% favorability. In traditional media, we go from 76% favorability to 80% favorability. So, journalists and mainstream media outlets are writing about GMOs in a very favorable manner. And when we talk about favorability, we actually include neutral coverage as favorable, right? So we consider neutral coverage to be science-based, and science-based is good. That's a favorable thing. And so, we saw some fantastic coverage just recently. Jennifer Kahn had that amazing piece about, inspiring us to learn to love GMOs in the New York Times Magazine last July. So there's just a lot of really great, robust writing happening out there. I think we've lost this sense of false balance that you have to sort of, treat both, pro GMO and anti GMO on the, in the same article and all this. That's kind of a thing of the past, because as we've seen, in previous slides, all the scientific consensus around the safety of GM crops is clear. And so it's great to see that journalists are reporting on it in a much more science-based way. And even in social media, which can be a total Wild West show, on social media, anybody can be an expert, anybody can jump in on the conversation. We still see the conversation much more favorable over time. So 62% in favorability in 2018, and now as high as 78% in 2020. So the conversation is a favorable one. We're on an upward trend line across all types of media. And I think that's a great proxy for, what the broader, societal feeling about this technology is. I wanted to talk about some of the, funny trends that we saw in 2020. And one of the things that we saw was that in social media, we saw a real decrease in sort of anti-GMO conspiracy theories and conspiratorial content in general. And that's likely due to this increased focus on COVID conspiracy theories by accounts that tend to promote those kinds of messages. And I want to share an example of that. So when we look at the top sort of influencers in this space on Twitter, for example, in 2018, 2019, and 2020, we see often some of those same accounts in 2018 and 2019 come on that top 10 list. And two of the sort of dominant accounts are Farm Fairy Crafts and also this other group called Trade Alerts. And one of the interesting observations was that when we shifted from 2018 to 2019, you still see Farm Fairy Crafts and Trade Alerts among those top 10. But then you go to 2020, and there's a dramatic decrease in the kind of influence that Farm Fairy Crafts is having. And it turns out they're really just not even talking about GMOs anymore in 2020, like they had been in previous years. Now, Farm Fairy Crafts is an actual Twitter account. Trade Alerts still stays steady in 2020, and that's because Trade Alerts is a bot, right? So they've just kind of programmed their message and it's still there in 2020, whereas Farm Fairy Crafts is an actual account, and they've clearly shifted their focus away from GMOs to other issues. Okay, so what are those issues? It turns out they're talking about miracle cures. And in 2020, there was this enormous shift to talking about miracle cures in light of the pandemic that we're living through. And when our team did a study, and this is a little bit of a diversion from the topic, but I think it's interesting to kind of connect these dots. Our team did a study in 2020 to look at COVID misinformation in the media. And one of the things that this study showed, and you can read the full study on our website, the link is there. And if you Google, misinformation study, COVID Alliance for Science, you'll find it. But one of the things that we saw was that there were these themes of misinformation in the sort of that made up the COVID misinformation landscape. And by far, the largest sort of sub-theme of misinformation was this miracle cures bucket. So miracle cures misinformation covered misinformation around the role that UV or hydroxychloroquine or disinfectants could play in helping prevent or cure COVID. And so, this is a big bucket of misinformation. It comprises more than all of the other 10 subtopics combined. And so what we see is groups like Farm Fairy Crafts that were talking about GMOs have now shifted their focus, and now they are are promoting these miracle cures and selling all kinds of products, of course, that could serve as these unscientific miracle cures for COVID-19. So it's just a really interesting year that maybe GMOs and that controversy wasn't selling and wasn't quite as hot as the miracle cures conversation. So kudos, they're great entrepreneurs, but they're not standing with the science.
Yeah, I guess that was my next question is this like a chicken and the egg problem? Like, do we know, did people's opinions on GMOs change first and then all the misinformation people kind of gave up on it? Or was it vice versa? Did the misinformation folks just switch to miracle cures and then did public perception change because of that? Or is there any way to tease that out?
Yeah, I mean, I don't have like really clear data on that, but since I've been following this issue for, 15 years now, since working on my PhD dissertation, even when we're looking at the controversy around various biotech crops in developing countries, what becomes clear is that a lot of the anti-GMO sentiment has been a real moneymaker, a real business opportunity for organizations. And it's in our human nature to be cautious about things that are new, right? But as the science became clearer, many of the more science-based environmental organizations, for example, have revised their positions on biotechnology, have realized the role that biotechnology can play in helping us, step up to the challenge of improving the environment and improving agriculture. And so, those are organizations who have listened to the science, who have changed their views and now are a very different place than they were in, the early 2000s. And it's those groups that are just sort of dogmatic and kind of, staunchly zero tolerant, when it comes to GMOs. Those are the groups that are essentially making money off of this GMO debate. And they have no motivation, right? No incentive to listen to the science or to change their minds on GMOs. But this is a small, tiny, number of organizations and groups of people. And so, the show moves on, the world moves on. We've got challenges before us, and the science is clear.
Yeah, following the money on that stuff, that's a whole nother topic.
Yeah, that'll be another webinar for you.
Yeah. But you mentioned, some of these great new crops that are having impact around the world, and you mentioned BT eggplant. I was wondering if you could, tell some of those stories, because there are some really cool stuff that's coming out these days.
That's right. There are so many great stories of applications of biotechnology that are really making a difference in people's lives and making a difference for the environment. So, you mentioned BT eggplant. This, of course, is one of our favorite stories. It has a connection here at Cornell, and it's a great story because this is a crop that just came onto the market in 2014 in Bangladesh, and now just a few years later, we can sort of look at the data and see the impact that it's having on people's lives. So I'll back up and tell you a little bit about this story. I'll tell it through the eyes of Mohammed Milan Mia, this farmer here from Bangladesh, who's a real champion for biotech eggplant. This is eggplant that has been engineered to have the BT gene, which makes it resistant to its most devastating pest, the fruit and shoot borer. And Milan was one of the first 20 farmers in Bangladesh to have access to this eggplant. In 2013, it was approved by the government there. On the right, there is the former Minister of Agriculture, the Honorable Matiya Chowdhury. And she, ensured that this technology would reach the hands of Bangladeshi farmers. She did not want Bangladeshi farmers to lose out on the biotech revolution. So she was very passionate about ensuring they had access to this technology. So it was approved in 2013, and then farmers like Milan were growing it and able to market it and sell their crop in 2014 as pesticide free, because they didn't have to spray the insecticides that they had to spray with conventional varieties.
They didn't have to spray at all.
That's not necessarily true. I mean, this is a technology that protects eggplant from its most devastating pest, the fruit and shoot borer, but it's not a cure-all. It doesn't protect eggplant from all diseases or all constraints. And so to say that you don't have to spray at all is not probably a true statement in most cases. That said, it has dramatically reduced the need for insecticides. So it has a great environmental impact. The farmers, now we can look at the data since 2014 to present, and we see that farmers on average, and I can share this slide with you here, are using 62% less pesticides. So that's a huge environmental benefit. There's so much less pesticide, going into these fields in Bangladesh. And what's more, due to fewer inputs, higher yields, better productivity, and great prices in the marketplace, the farmers are experiencing on average a 6-fold increase in their income. So that's just absolutely transformative. I mean, that's the difference between a farmer in Bangladesh making, $3 a day to making $18 a day. And so that's, offering Milan and his family the opportunity to, make new choices in their lives and have access to new resources and to live fuller lives. So that's one example of a technology that's just been out there, for less than a decade, that is having a huge impact, not only on the environment, but on farmers' lives and, smallholder farmers. This is a technology that was developed by Bangladeshi researchers, and it's meant to serve Bangladeshi farmers. So it's a really, really great story that I think we haven't told enough. And there's so many more stories like this. This is a 19-year-old farmer in Nigeria named Osman Yahya Al-Hassan. He was one of the first farmers in Nigeria to grow a new GMO that's out there now, and this is Bt cowpea. So just like the eggplant, it has the Bt gene in it that protects it from one of its devastating insect pests. And, this was just approved by Nigeria, and farmers like Osman were able to grow it this year and have, amazing Bt cowpea harvests. And, AJ, you and I, we don't thrive on cowpea, right? This is not a critical part of our diet, I'm guessing. But for people in Nigeria, this is a major staple, and it's a great healthy source of protein. So when we think about, using biotechnology to improve the environment, like a Bt gene is great because it reduces insecticide use, but it also does a great service to improving nutrition. These beans are highly nutritious, and I've talked to people in Nigeria, and when production becomes so challenging, the price goes up, and people can't afford to buy their cowpea, their beans, as they call them. And so, they're missing that very essential and nutritious part of their diet. So this is another great story. And I think we're going to continue to hear stories from Nigeria as farmers are able to grow this exciting new bean, and we'll see the difference that it makes. So, I actually am really excited because in the last year, there's been some really exciting approvals out there. So, it's not just about corn and soy and canola anymore. There's so many exciting biotech crops that are out there. We just had a pinto bean approved in Brazil, another great source of protein. The eggplant that has benefited farmers in Bangladesh so dramatically was just approved for food and processing in the Philippines. So it might be able to have the opportunity to benefit farmers in the Philippines, just like it has in Bangladesh. And the Philippines, they were on a roll this year. They also approved golden rice. And this is a story I think many of us have heard, a long-awaited technology that really can contribute significantly to child and maternal health, and be a great source of provitamin A that will help address the devastating impacts of vitamin A deficiency across Asia, where rice-dominated diets persist. So these are some really exciting crops that are coming online. And so again, it's a new day. And there's so many exciting crops that are out there. So we have a lot of friends in Africa at the Alliance for Science who are developing really exciting technologies, friends at the AATF, for example, or the national programs such as the National Agricultural Research Organization in Uganda. A lot of great science happening at these institutions, really trying to use this tool to improve the crops that are important for farmers and consumers across Africa. And there's been some really exciting developments in the last couple of years in Africa. Now we have 6 countries that are growing BT cotton or that have approved BT cotton. We've seen 2 maize approvals. So this is for drought and BT, and I'm expecting that there will be more of those just around the corner. We have the BT cowpea, not only approved, but being grown by farmers. And I just want to, give a shout out to Nigeria, who's really, driving this forward. They've approved cotton, the water efficient maize for Africa, that's going to really help farmers grow maize, a very important staple in Africa, despite the devastation of the fall armyworm, a major pest there, as well as erratic rainfall and all of the impacts of climate change. And then, of course, they're leading the way on this cowpea. And so, it's exciting to see countries sort of putting the politics aside and saying, hey, this is what our farmers need. This is what our people need. We're going to stand with the science, and we're going to approve these crops in order to have impact.
Yeah. So real quick, do you see these approvals around the world? Are they impacting, or are they shifting public sentiment on GMOs in the US and Western Europe at all, or are people even noticing them, do you think?
Yeah, that's a really good question, AJ. I hope that they make a difference. I think when Nigeria shows leadership like this and pushes forward, it means a lot for the region. It means a lot for other countries on the African continent. I know that, farmers across Africa have been looking at South Africa for a long time and saying, hey, look at that beautiful maize that they have, that biotech maize. We'd like to have it too. Now, is this having influence on conversations in the West, in the well-fed West, where, a lot of this anti-GMO sentiment was first born? I don't know. I think, when we look at kind of what narratives around GM crops are sort of resonating in the US and Europe versus other parts of the world, sadly, it doesn't seem like people change their minds based on what's happening in Africa. Most people aren't motivated to change their views, to change their consumer habits in the US based on, the dire food insecurity in other corners of the world, which is really sad and frankly immoral. And this is, I have a good friend, Patricia Nanteza, who's a fantastic science communicator from Uganda. And that's really her message is, you people in the West, let us make our own decisions. Don't impose your values on us because we have different challenges. Okay, so let Africa, her message is let Africa speak for herself. And I think, that's a message that all of us in the West need to hear. That our consumer habits here do actually have impact in other parts of the world, and so it's all the more reason to be mindful of the way that we behave as consumers here in the West.
Yeah, I can't agree with that more. That's exactly it. And I like the way you put it. We're the well-fed West. We can pay 70 cents a premium for organic or whatever. Not everyone can do that.
That said, if there's one, COVID has exposed a lot of our vulnerabilities, our food deserts here in the West as well. And so, the well-fed West and the well-fed elite West, not everyone in the West has access to safe, nutritious food either. And so I think we do have some challenges here as well.
Yeah, and there's quite a few questions in the chat about misinformation around COVID. Could you talk a bit about that and the links between the COVID vaccines and GMOs? Yeah,
it's interesting. I think you asked the question, what changes people's minds, right? Is it these success stories in Africa, or why is the GMO debate over, right? Why are people changing their views on GMOs? And whether you're a science-informed environmental organization that's changed their views, like the Environmental Defense Fund, or whether you're just an individual consumer who's changing their views. So why are people changing their views, if not, for the betterment of food security and other places? I think the big driver is climate change. And I want to share one slide about this. So we have this enormous challenge before us that, we have to feed the 10 billion people by 2050, which is a huge challenge. And it's an even bigger challenge because, of course, feeding people means agriculture, and agriculture is a big contributor to climate change. And, whether it's greenhouse gas emissions, deforestation, the loss of topsoil loss, draining of the world's, water resources, it's a major contributor to climate change. And so we need tools to do agriculture better if we're going to both at the same time address our changing climate while feeding the many. And I think this is the issue that it's a huge looming challenge, and especially young people. They are, yes, let's embrace technology that's going to help us address this challenge of feeding the many while sparing the planet. I mean, that's really, I think, a major driver for people to change their minds on GMOs. We've got to do everything we can to save this planet. And if, changing your mind about GMOs is part of that, let's do it. And so that gives me great hope. And then, the other really interesting driver, and this gets more to your question, AJ, is, one of the sort of the opportunities in the COVID crisis is that, in the news cycle, it focused heavily on COVID-19 for very good reasons, right? We relied on our news to, take us through this pandemic, to bring us good information. Some of it not so good, but much of it very good. And we did see this sort of drop overall in coverage of the GM issue. That said, we did see the GM technology, the biotechnology theme very much associated with the development of the vaccines that are going to get us through this pandemic. And so I think that's sort of offered kind of had a halo effect on the conversation around GMOs. People today understand the role that biotechnology played in developing these life-saving vaccines. And that's a good thing. And so that's another driver for people to sort of say, hey, we had this enormous challenge. We needed to develop a vaccine. Biotechnology was there to help us do it. And so great. If it can save us during a pandemic, maybe it has something else to offer to improve lives in other areas. And so I really see this as an opportunity in crisis. We've weathered a long 2 to 3 decades of a GMO debate, but farmers love GM crops, right? They see the direct benefits. They see the reduction in insecticide use, the cleaner, greener way of doing agriculture, the way they can produce more food using fewer resources. And so I think that's, it's seeing is believing. Farmers love this technology. And now with gene editing and CRISPR, we're seeing more exciting products being developed that are more consumer facing. So we're going to see in our produce aisle really exciting, healthy, nutritious foods that are going to help us, lead our fast, convenient lives while also consuming much more nutritious foods. And so I think, for the last couple of decades, the benefits have really been to the producers. And in a place like the US, that's less than 2% of the population. But what we're going to see moving forward are products coming out that are going to benefit you and me, just regular consumers who are walking in the grocery store and excited to have access to new fruits and vegetables and healthy foods. And so, we're really kind of, pushing back now on, as people, as regular people, not just as the Alliance for Science, but as regular people, we're pushing back on this misinformation. We've seen how devastating misinformation can be when it comes to climate change, when it comes to COVID-19. And we see like, oh, this is the same bad misinformation and disinformation in the GMO debate. So let's push back on that misinformation and stand firmly with the science, and then we'll see the way that the science, this great technology, can be used to develop products that are really going to have impact and allow us to address these big challenges of feeding the 10 billion people while at the same time sparing the planet. So young people know this. They're behind it. Like, yes, let's use the tools of today to protect the planet tomorrow. And so, AJ, that's why I think the GMO debate is over.
Nice. That was a good I hope you're right. That sounds really good to me. And that was a good way. And we have a ton of questions. I'm sure we won't be able to get them all, but let's try it.
Great. And I'm happy to continue the conversation too online. I put my email address up here too. So yeah, let's jump in, and also happy to continue the conversation any day, anywhere.
All right, that's good. So let's pick up where you ended there. One question: anti-vaxxers were a relatively small fringe group before COVID, but now are having a huge impact on society. Is there any chance that the fringe anti-GMO group could become more influential again in the future?
I mean, I would argue that their day is over, that they've been found out. I think it's a very small vocal minority, as I said, and I think it's not the issue of today. So if you divide it kind of into two groups, there's sort of the anti-GMO folks who have it's baked into their business model to be anti-GMO, and they might continue to clamor on, or they might move on to other issues that are more lucrative, like peddling cures for COVID, as we saw in 2020. But I think most people realize that that we can't afford to quibble over whether something is GMO or not, and then they start to realize that GMOs are all around us. We've been consuming GMOs. We have them to thank for having a plentiful food supply, a plentiful cheap food supply, especially in this country. And again, as we see products coming online that are developed using biotechnology that benefit us as consumers, we might just get over ourselves and embrace those products. I mean, people often use sort of the cell phone analogy. I don't know how my cell phone works. I've heard that it causes brain cancer, but I still use it. It's still next to me, right now and every day, 24/7, because it has tremendous utility for me. It's really useful. And I think, farmers have enjoyed the utility, the usefulness of biotech crops for more than a couple of decades now. Consumers haven't had that direct relationship with a biotech crop, at least in the US. In a country like Burkina Faso, a consumer and a farmer is the same person, but that's not necessarily true where these debates have been born. And so I think as we receive the utility, whether it's in the form of a vaccine or whether it's in the form of a convenient, healthy vegetable, we're gonna change our views.
Yeah, that just triggers a memory. Like, we've been benefiting from GMOs for so long. Like, even cheese now. Most cheese is made using enzymes that were produced in genetically modified yeast. People aren't going around collecting cow stomachs for rennet en masse anymore. You know what I mean? Like insulin, like all kinds of things, and you just never hear that story. So I don't know. I think there's more. There's people have been benefiting. They just haven't realized it, I don't think. Here's one question. Could you let me know the source of the numbers on the visibility of GMO slide?
Yeah, actually, that's a paper that we have coming. It's under review right now. It's not even hot off the press yet. It's an early view into some data that we're publishing right now. And so if you stay tuned on all the Alliance for Science channels, you'll get a note when that comes out, hopefully by the end of the year. But yeah, that'll be made freely available, and all the sort of supplemental info and all of the methods that informed that data collection will be published hopefully very soon.
We'll be sharing that as well on the BTI site.
Absolutely.
Sure. Here's one from Masib Mugwanya. Thanks, Sarah. I'm curious what your thoughts are on the real conversation we should be having on GMOs that does not make it to mainstream debates, especially on their relevance to smallholder farmers in the developing world, which we talked a bit about, but I don't think can be emphasized enough.
Yeah, thanks, Nasib, for this question. It's something I feel really passionate. Well, my response to your question is something I feel really passionate about, and it's something I think that BTI is playing an active role in helping address. So the real conversation that we need to be having is about access to these tools. And, we have the conversation about farmers having access to the seed, but I want to also have the conversation about young scientists having access to the ability to innovate using these tools. So right now there are, I think, 13 at last count, and, plus or minus one if my memory is not serving me, 13 genetically engineered crops on the market somewhere in the world. Only 13. There's no tomatoes, no watermelons, like it's just a very small number. And that is, I think, one of the biggest failures. And it's because, the people who have opposed this technology have made it so difficult to use these tools to innovate that it's discouraged so many innovators, particularly innovators in the public sector, innovators across developing countries, the developing world, as Nasib points out. And so we need to create an innovation environment where young researchers can have experience using biotechnology and then develop the kinds of crops with the kinds of traits that are important to the people in their countries. And so I think that's where, BTI can play a role, as well as public plant science and research institutes around the world can play a role in really inspiring that kind of innovation, so that we can, really reach the potential. I mean, the sky is the limit. There's so much innovation that can happen, but we need young people to feel like there is an opening there to use these tools to innovate, to have impact.
So there've been a couple of questions related to like intellectual property around these products, and are there hurdles to that being shared or given to the farmer? Like, who's profiting off these? How profitable is the cowpea product for the company that developed it, for example? And what are some of these other hurdles that you see?
Yeah, so I mean, when you think about, like, corn and soy and these big globally traded commodities, a lot of those seeds, those are developed by companies who do need to respond to shareholders who have to show profits. But a lot of the stories that we're trying to tell are stories that are not about profits, right? Stories that are about philanthropic organizations, about public researchers who are using these tools to innovate. And in those cases, there is no there's no profit model. So when you talk about that cowpea, for example, that was developed by the African Agricultural Technology Foundation, AATF, in partnership with the national programs in Nigeria and then also in Ghana and potentially other places, with funds from philanthropic organizations, such as the US aid agency. And, the technology is usually, if there's technology involved that isn't originated from those organizations, it's often donated by a company, because those companies often realize, like, they're not going to make a lot of money on improving cowpea, which is why not enough of those specialty crops have been developed or improved using biotechnology. And I say specialty crops, but in many cases, these are food security crops. These are subsistence crops. These are very important staples, like improving cassava, for example. That's a staple in so many parts of the world. So, in those cases, these are not big companies, developing these products to sell seed to smallholder farmers to make money. These are philanthropic efforts, or these are efforts being led by national programs. We had a questioner earlier from Uganda, and the Uganda National Program, these public servants who work for the National Agriculture Research Organization of Uganda, they are using these tools to make better bananas that are going to serve Ugandans. They're using these products to make virus-resistant cassava or healthier cassava, healthier sweet potatoes. These are crops that the big seed companies, the big multinationals, might not be interested in, but it's the national researchers, the public researchers who are using these tools to make sure that those crops are improved too. So, that's another reason why we can't just lump all these GMOs into one bucket, one monolith, and say GMOs are good or GMOs are bad. Like, we've got to unpack that, and we've got to look at who benefits. What are the risks? What are the costs? What are the implications for smallholder farmers or for the success of small businesses, small startups? So it's never simple. It's never black and white. You've got to unpack it and look at who benefits. And in many of the stories that we're telling around eggplant, cowpea, sweet potato, cassava, the profit motive isn't there.
Right. That's great. That's good to hear. And I remember even with the golden rice, all the places that had patent cover, there were a lot of them. That was one of the first stories I wrote about 20 some years ago about Monsanto and some other places in like Switzerland, I think. They all just basically gave up their patent rights and said, use them, develop this product and help prevent child blindness, basically. And it's taken this long. But to get back to some of the US stuff, here's a question from David Silberman, a BTI alum. Hello, David. This question is, prior to the introduction of GMOs, US farmers either saved seed or relied in part on seeds developed by land-grant schools, including Cornell. Could you comment on how patenting genetic sequences has contributed to the GMO controversy, beginning with Percy Schmeiser v. Monsanto, which I believe is that Canadian Supreme Court case. I think that's that guy's name. And how does reliance on corporate seed distributors impact farmers with respect to their financial bottom line? So it's kind of a history.
Yeah, there's a lot here. I'm kind of reading along here.
I didn't read the whole thing. It's a really long question.
Yeah, I mean, there's a lot of, like, agriculture is complicated and agribusiness is complicated. And oftentimes this question of, like, when farmers save their seed, can farmers not save their seed, gets sort of aggregated with the GMO conversation, and it really needs to be pulled apart. Because long before there were GMOs, there were farmers who decided that they wanted to buy seeds. They wanted to buy improved seeds each year because it offered them a better yield, right? So corn farmers in the United States have been choosing to purchase their corn seed year after year, hybrid corn seed, because it means they make more money. They get higher yields, they make more money. It's all about their bottom line. So they might have to spend a little bit more upfront, but they make more at the end of the day. And that's a decision that a farmer makes. And it's a decision that a farmer makes in the US when buying corn seed, and it's a decision that a farmer is going to make in Nigeria when choosing what kind of cowpea to grow. That's a farmer's decision, and farmers are smart business people, and they make those decisions based on what's available to them, what resources they have, and the economics as they calculate them. And I think it's really important for us to pull that conversation away from the conversation about genetic engineering, because whether a seed is genetically engineered or not is sort of independent of whether a farmer chooses to buy seed or save seed, whether they choose to grow open pollinated varieties that may not actually yield as much, or whether they choose to buy hybrid varieties that may yield better. I will go back to the eggplant story for just a moment to say that in the case of eggplant, the government of Bangladesh first approved openly pollinated varieties of eggplant, of genetically engineered eggplant. So in this case, farmers can save their seed, they can grow it again, and there's no need to continue to buy the eggplant seed, and it was free anyway to begin with from the government. But the idea is that the private companies that did donate some of the technology, could at some point come in with hybrid varieties of those eggplant, and farmers could choose at that point. And this isn't happening yet, but farmers in theory could choose whether or not to continue to grow open pollinated varieties, or whether they would want to go to their seed company and buy a hybrid version of that, which might yield better. And though that decision is the decision that a farmer has to make based on their own economic analysis. But it's not something that's imposed on them by a seed company or by the government for that matter. So separate the issues.
Yeah, I kind of see patents in that same realm. A lot of people oppose GMOs because of patents, but a lot of non-GMO crops and seeds are also patented. So there's
patented products are all around us, and we're buying them all the time, and we're paying for those patented products. We're paying for that innovation, right? And the companies that dare to innovate are getting a return on their investment, and so that's all around us, far beyond agriculture. As consumers, we make those choices whether to pay for that innovation.
Okay, we're almost out of time, so I'm going to do one last quick question. Do you include CRISPR as a GMO technology? Can you distinguish the debate over transgenic and CRISPR?
Sure. Well, I would say that, like the term GMO actually includes every living organism. We're all genetically modified, right? I mean, any organism that, is produced with, through sex is a genetically modified organism. The chromosomes get mixed up, the DNA gets mixed up. We're all genetically modified organisms. So the whole term GMO is a bit misleading to begin with. We recognize today that we're using it in the sense of, this is a crop that's been developed using recombinant DNA technology, where we move a sequence of DNA from one place and move it into another organism, another plant, in most cases that we've talked about today. So that's how we're using the term GMO today. Whether it's scientifically accurate or desirable is a bit besides the point, because frankly, it's the term we're stuck with, and it's the term that's on a lot of packaging all over our grocery store shelves. So we just sort of have to use it. Now, CRISPR. CRISPR is one of the tools that falls under genome editing. It's an exciting new field that holds so much potential. And I do think it's different. It is a different technology. It's different in the way that it works. It's different in the way that scientists are able to make very subtle changes that would happen in nature anyway in order to improve crops and livestock, for example. So it's not GMO in the way that GMO has been used, in popular culture. I hope I answered that question.
There are tons of more questions, and unfortunately we can't get to them, but maybe we could, in this afternoon or sometime in the near future, we could go through them and email some answers to folks.
Great. Yeah, and we can keep the conversation going on social and elsewhere. So happy to continue.
There are a lot of really good questions. Yeah, I wish we had more time, but we try to keep it an hour. So thank you, Dr. Sarah Evanega, for taking the time to be with us today. And
thanks, AJ.
Thank you to everyone out there who joined us. This was really great. A lot of great questions. And I'm going to put some links in the chat. And if you could please click on that first one, btiscience.org, and join us for our next Breaking Ground discussion series on Wednesday, November 17th. We'll be with Zhongjun Fei, who will be talking about watermelons. So if you want to, pretend summer isn't over yet and hear a lot of really neat stuff about watermelon, how it evolved, how it's been used in breeding, a lot of cool stuff has been happening with watermelons over the past couple of years, and Fei's been right in the middle of it. And you can also read more about BTI's current research and many other neat stories about BTI science in our annual report, which you can find online at btiscience.org/annual report. And the 2020 annual report is all digital with 3 different views. There's a single-page view, a 2-page view, which is most similar to reading a hard copy. And then there's a reading view, which is like reading an article on the web. So it's like an HTML thing, which is also good for your phone. And there are many links to videos and other neat interactive aspects in the online annual report, which you can find there. And BTI is an independent nonprofit research institute, and we operate in large part thanks to the generosity of community members like you. And if you'd like to make a gift to support BTI, you can donate online at btiscience.org/give, or email our development team at development@btiscience.org. And thank you all for your interest and support of the Boyce Thompson Institute. And thanks again, Sarah. And have a wonderful day and be well. Bye, everyone.